Welcome to Educator.com. Today's lesson is functions and graphs. First, we're going to be defining a function, discussing what a function is, and then we're going to go on to graph functions. Okay, a function is a rule that assigns to each value of one set exactly one value of another set. This is most easily understood through an example. Let's say that I have two sets, set 1 and set 2. And my values for my first set are 2, 3, 4, 5. And then my values for my second set are 4, 6, 8, and 10. If I say that one value from set 1 corresponds to exactly one value of set 2, I have a function. So this is an example of a function. The first set, the important thing is that members of the first set correspond to only one value from the second set. If they correspond to more than one value, it is not a function. Let's take two other sets, set 1 and set 2. 7, 8, 9, and 10, and -1, -2, -3, -4. If I have 7 corresponding -1, I'm okay so far, and 8 corresponds to -2. But let's say that 9 is assigned to, or corresponds to, -2 and -3. And then 10 is to -4. This is not a function. If a member of the first set is assigned to more than one value from the second set, because 9 is assigned to -3, and it's also being assigned to -2, that is not a function. However, here's one more case. In my first set, perhaps I have 1, 2, 3, 4, and then I have 10, 12, 14. And 1 is said to correspond with 10, 2 corresponds with 12, 3 corresponds with 12, 4 corresponds with 14. This is a function. These share a value, 2 and 3 share a value from set 2. But what I'm looking at is, is each member of the first set assigned to only one member of the second set? And yes, 1 is only assigned to 10, 2 is only assigned to 12, 3 is only assigned to 12, and 4 is only assigned to 14. Therefore, this is also a function. There's a broader term that encompasses this middle situation as well, and that is a relation. A relation says that there's a correspondence between the numbers of two sets, but it's not as restrictive as a function. So this first one is a relation, but it's also a function. The second one is not a function, but it's still a relation. The third situation, again, it's a function and a relation. Sometimes we describe functions as equations, such as y equals 2x. And what I'm going to do to generate my set of values is I would have a set of values for x that I will plug in, and let's say I let x equal 2. So if I plug that in, I'm going to find that y equals 2 times 2, or y equals 4. And that's one of the values up here, actually. So sometimes I can explain a function as an equation. Sometimes the function is just a given set of numbers. Other times it's described by an equation. Frequently, you'll be asked to graph functions, or you'll be given a graph of a function. And what a graph of a function is a visual display of the function on the coordinate plane. I'm going to call the two sets X and Y because the two sets there's still set 1 and set 2, and I'm still talking about a function, but a lot of times in algebra what you're going to see is this first set called X and Y, and then we can go ahead and graph them on a coordinate plane where we have the X-axis, the horizontal axis, and the Y-axis. Okay. So let's say I'm given 0, 1, 2, 3, and 4. And I'm going to graph these. 0, 2, 4, 6, and 8. What we can do when we're given sets such as these and told that the first one corresponds with the first member of the table and on, is we can form what's called coordinate pairs. Coordinate pairs tell us the coordinate of a point on the coordinate plane. For example, looking up here, I have 0 and 0. So my first coordinate pair is 0, 0. With the coordinate pair, by convention, the first term is always the X term and the second is the Y term. So in my coordinate pairs, they're always going to be in the order X, Y. For my second set of coordinate pairs, I'm going to have 1 and 2. My third set, 2 and 4. My fourth is 3 and 6, and finally 4 and 8. And I can graph these points. Here at the origin of the coordinate plane, so the point 0, 0 is called the origin, and I'm looking and I do have a 0, 0. I'm going to graph it as a point right there. Okay? Now, my next set of coordinate pairs is 1, 2. So 1 and 2. In order to graph this, I'm going to go over to 1 on the x-axis, so over 1 horizontally, and then I'm going to go up 1, 2. So first I had my point, my coordinate pair 0, 0, and then next I had 1, 2, 1 over 1 up 2, so the x is 1, the y value is 2. For the next coordinate pair, I have 2, 4. 1, 2, and then up to 4 on the y-axis. Three, 6 would be over 3 on the x-axis, and then 6 is going to be about up here. And then 4, 8 would be my next point. What I'm given here are a set of discrete points, and I can't just form a line out of them because I am not told for sure that there are other points between here. And when you have a set of when you make a graph of a function and it's actually a set of discrete points, that's called a discrete function. And it just forms a set of discrete points on a graph. Now, let's say I had another graph, another function, and it ended up coming out as a line on the graph, such as this. That would be called a continuous function. So a continuous function, when graphed, the graph of this forms a curve or a line. So this is a continuous function. What I have up here is a discrete function. So we covered quite a bit of terminology, but looking at this carefully, what I gave you was a table. And I said that the values of x in the first set each correspond to one value of y in the second table. So I have a function because each value of x is assigned only one value in that y set. I was able to use these to form what's called coordinate pairs. And The common way that this is expressed is parentheses with the x term first and the y term second. So I used my values in these sets to form coordinate pairs. Next, I went over to the coordinate plane and I graphed these points on the x and y axis, noting that the first term is the x term, so it told me to go 1 over 1 on the y-axis and then up 2. Excuse me, over 1 on the x-axis and then up 2 on the y-axis. This gave me a discrete function. It's a set of points on the graph that were not connected. However, I could have an equation, for example, describing a function, and that might generate a line or a curve on a graph that I could use to, and that is called a continuous function. Now, we defined a function as a situation in which each value from the first set, usually x, is assigned only one value in the second set. And there's a way to test for that visually. And the vertical line test allows you to test if something is a function. And the reason for this is that if there are two points that have the same x value, they're going to lie directly above or below each other on this coordinate plane. Okay, let's look at this situation. If I drew a vertical line, so here's my graph, and let's say I drew a vertical line here. If the vertical line passes through more than one point on the graph, it is not a function. If a vertical line passes through more than one point, then the graph you have is not a graph of a function. The reason for this is, let's look right here at this line that I drew. It's at about 1.5. So the value, this first set of values is, say, 1.5, and then there's a y value. This second point is also at 1.5, and it's got some other y value higher up, say 2.5. I go up here to where my vertical line crossed, and I see again x is at 1.5, and I've got another value for y, say 4.5. So the situation I'm ending up with is that I have x is 1.5 and there's a y value. Then I have x is 1.5. There's another y value. X is again 1.5 and there's yet another y value. And that is not a function, because you cannot have a function if a member of the first set is assigned to more than one member of the second set. So if x is assigned to more than one y value, it's not a function. So what I have up here is not a function. Let's take a different case. Let's say I have a graph of a line right here. Now, if I look at this line and I put a vertical line through it anywhere, it's only going to pass through one point on the line. This passed the vertical line test because my vertical line passed through only one point on the graph. This did not pass the vertical line test, so it is not a function. And that is a visual way of deciding if you have a function or not. Sometimes we describe the first set of values, or x values, as the domain, and the second set of values, or the y values, as the range. Suppose f is a function that takes values from one set x and assigns them to values in another set y. We call the set x the domain of the function f, and the set y the range of f. For example, I could have a set of x values, 1, 2, 3, and 4, and a set of y values, -1, -2, -3, -4. And I could then say that my domain is 1, 2, 3, and 4. And commonly, we use brackets to show the domain, the range, or the entire function or relation, the set of values. The range for this function is all of these y values. -1, -2, -3, -4. Mentioning last time about coordinate pairs. I can generate a set of coordinate pairs for each of these. 1, -1. 2, -2. So remember, the x value is first, the y value is always second. 3, -3, 4, -4. And I could place these into brackets as well, describing the set of coordinate pairs for this function as 1, -1, 2, -2, and on. Okay, in example 1, the function f is given by this table, and what we're going to do is discuss this function and then generate a graph. In order to draw a graph, what I need to do is first get some coordinate pairs out of this table. So my first one is 0, 1. My second is 1, 3. And then I have 2, 4, 3, 2, and 4, 6. So double checking that I have all these correct and that my x values are first and that my y values are second. I'm going to go over and I'm going to look at my coordinate plane, and my first value is 0, 1. Therefore, I'm at 0 on the x-axis and at 1 on the y-axis. That is for my first coordinate pair, 0, 1. For my second coordinate pair, x is 1 and y is 3. Then, next pair, I have x at 2, so I'm going to go to 2 on the x-axis and then up to 4 on the y-axis. Then I have 3, 2. So x, 1, 2, 3, and y is down here at 2. And then finally, 4, 6. X is 4, y is going to be a little bit up here over at 6. And I am not going to connect these because I don't know which way this is going to connect, if there are even points in between. All I'm told is I have certain x values and certain y values. So I have a discrete function, and it's just represented by points on the coordinate plane. So remember, in order to graph a function, what you need to do is generate a set of coordinate pairs that you can use to locate points on the coordinate plane. Here's a different example. Suppose that gas costs $3.50 a gallon. Make a table that shows the cost of buying 1, 2, 3, 4, or 5 gallons of gas. Then write the data as a set of ordered pairs and graph the ordered pairs. We're being asked to do a bunch of things, so let's take them one at a time. First, we're asked to make a table that shows the cost of buying 1, 2, 3, 4, or 5 gallons of gas. So for my first set of values, for my x's, I am going to have the number of gallons. 1, 2, 3, 4, or 5. And then for my y value, I'm going to have the cost of that particular number of gallons. And since 1 gallon costs $3.50, I'm going to take the number of gallons and multiply by 350 to get y. My second gallon of gas, if I buy 2 gallons of gas, it's going to cost me $7. 3 gallons is going to be $10.50. 4 gallons, $14, and 5 gallons, 17.5. And this illustrates a point. We sometimes call X the independent variable. And Y the dependent variable. And looking at this, that makes sense. The value of X is the number of gallons. It doesn't, what Y is doesn't really matter. If I say that X is a gallon, it's a gallon. It's independent of Y. However, the value of Y depends on X. Think of it as this way, that the value of Y depends upon X. So if I have 2 gallons of gas, the cost is going to be $7. So the Y, the cost, depends upon how many gallons I have. So this is the independent variable and the dependent variable. Okay. So I was first asked to make a table that shows the cost of buying 1 through 5 gallons of gas, and I did that. Then I'm supposed to write the data as a set of ordered pairs. And I'm going to do that by writing my X value followed by my corresponding Y value. Okay, and now I need to graph the ordered pairs. For these, for X, I'm going to say 1, 2, 3, 4, 5. And for Y, I'm going to go by 5 so we can fit this all on. $5, $10, $15, $20. So X is gallons, Y is the cost. My first value is 1, 3.5. So X is 1, Y is right about here, 3.5. My second value is going to be, my second coordinate pair is 2 and 7. So 2 gallons of gas and then $7 right about here. My third value, 3 and then 10.50, so a little bit above 10. 4 is going to be at $14, so just below 15. And then 5 is going to be 17.5, so right about there. Okay. Now, again, these are discrete points. It only told me to graph 1, 2, 3, 4, 5 gallons, the cost of the 5 gallons of gas. It didn't say, okay, include 2.5 gallons or 2.33 gallons. Because if I did, and I could have an infinite number of points in between here, I could connect this into a line, but it's not asking me that. It's saying, here's your domain, here's your range, here's your set of coordinate pairs, graph only those. Example 3 is a slightly different situation. Suppose that gas costs $3 a gallon. You stop to fill your tank, which has a capacity of 16 gallons. Explain how the cost of gas you buy is a function of the number of gallons you buy. What are the domain and range of the function? Graph the function. Okay. So this time, it's telling me that my domain, let's talk first about the domain and the range, because in order to graph it, I really need to know what my domain and range are. My domain is going to be the number of gallons of gas that I can buy. So this is going to be my gallons. And I can actually buy any amount of gas above 0. I could buy just a half a gallon or less. Therefore, my domain is going to be any value of X greater than 0. But my tank only holds 16 gallons. So the maximum is 16. Therefore, my domain is going to be X is greater than 0, but less than or equal to 16. My range is going to be the cost. Now, the smallest amount of gas I buy is going to cost some amount above 0. So X can be the smallest amount above 0. The maximum it's going to be, the maximum for the range is going to be the maximum amount of gas I could buy, which is 16 times the cost of the gas, which is $3. So 16 times 3 is 48. Okay, this is a range, so it's y. And this is showing a different situation. Before, we talked about domain and range as a specific set of values. You know, domain is 1, 2, 3, 4, 5. Range is another set. But the domain can be an inequality like this. A domain could involve saying all real numbers. The domain is all real numbers, or the range is all positive numbers. So here we're seeing a broader definition of domain and range, that the domain is any value of x greater than 0 or less than 6 or equal to 16, values of y greater than 0 or less than or equal to 48. Okay, so I've figured out the domain and the range of this function. It's also asking me to explain how the cost of the gas that I buy is a function of the number of gallons that I buy. Okay. Well, there's a relationship between this first set, the domain, and the range. And the relationship is that the value of the range is going to be 3 times the x value. So y is going to be equal to 3x. That equation describes this function. Y equals $3 times the gallons of gas. And what I'm going to come out with is for every x value, I only have one y value. If I buy a gallon of gas, it's $5. If I buy 2.5 gallons of gas, 1 gallon of gas is going to be $3. If I buy 2.5 gallons, it's going to be a certain amount. And there's only one unique y value assigned to each x value. So I don't have an x with multiple y values. Therefore, it is a function. So I've determined my domain and range, and I've explained that this is a function. Now I need to graph. And the way I can graph is I can set up a table of x and y values. So let's say I buy 1 gallon of gas. The cost of the gas is going to be $3, looking at this equation. If I buy 2 gallons, it's going to be $6. 3 is going to be $9. And this is going to go on up to my maximum of 16 being $48. So if I say that, I have 1, 2, 3, 4, and on, and then on the y-axis I could have 3, 6, 9, 12, $15. I can graph these by forming some coordinate pairs. And what I'm going to see is that I get 1 gallon of gas is $3, 2 gallons of gas is $6, 3 gallons is $9, 4 is $12, 5, if you kept going, would be $15. Now, I actually can connect these to form a line, because what this is telling me is that I have a capacity in my tank of 16 gallons. So I could fill up any amount from just above 0, so that's going to be an open circle because it's just above 0, all the way up. And this is going to go on and on and on, and it's going to end when we get to 48. This is going to end with $48 way out here and 16 gallons up here. So the graph of this actually is a continuous function because I'm allowed to fill up with, say, 1.5 gallons or any number in between here. So I start out slightly above 0, so open circle, all the way on up to my maximum of 16 gallons for $48. In this example, a shipping company charges $5 per pound to send a package. The company always rounds up to the next pound to calculate the cost. The maximum allowed weight is 10 pounds. Explain how the cost of mailing is a function of the weight of the package. What are the domain and range of the function? Graph the function. Okay, let's start out by talking about the domain and range. What are we dealing with in terms of the domain? Well, the domain is going to be the weight of the package that I sent. The smallest package I can send is going to weigh more than 0 pounds. So the domain is going to be some amount of x, some number value for x that is more than 0. They're telling me, though, the maximum allowed weight is 10 pounds. So x is going to be less than or equal to 10. the range is going to be the cost of mailing. And the range is going to be different. The range is actually going to be discrete numbers because they're saying here that they always round up to the next pound to calculate the cost. So if I have a package that's 2.5 pounds, they're going to round up to 3 and charge me $15. So I'm not going to come up with an amount like $5.32. It's just discrete numbers. The cheapest is going to be $5. And then I'm going to go to $10, $15. And that's going to go all the way up to my maximum, which is going to be charged for 10 pounds or $50. So the domain here is x value greater than 0 and less than or equal to 10, while the range or the cost is 5, 10, 15, 20, and on up to 50. Okay, so I got my domain and range. Now explain how the cost of mailing is a function of the weight of the package. Well, the cost of mailing depends on the weight of the package. So if my x value is weight and my y is the cost, I have x as my independent variable and y as my dependent variable. And the cost of mailing is a function of, or is dependent on, the number of pounds, the weight. Okay, something interesting happens because of this rounding up and because of there just being discrete numbers in the range. Let's say I have a very light package. It's only 0.1 pounds. How much are they going to charge me? $5. Okay, let's say I have a 1 pound package. They're going to charge me $5. Fine, 1.2. Well, guess what? They're going to round that up and charge me $10. If I have 2 pounds, $10. If I have 2.3, they're going to round it up, $15. And on up, let's say I have 9.8, they're going to charge me, they're going to round up to 10, and they're going to charge me $50. Okay. So here's what I see is if I go over to my graph and I say, okay, x is going to be 1, 2, 3, 4, let's just go up to 5 pounds for right now. And then y is going to be $5 or 10, 15, 20, 25. Let's look at what happens. If I have a package that is anything over 0, maxing out at 1 pound, it's going to be $5. So that's going to be an open circle at $5, ending with a closed circle, an open circle at 0. So a little bit above 0, all the way up to 1 pound, that's going to be $5. If I have half a pound on my X here, it's $5. If I have 2/3 of a pound, it's $5. Then, when I get to slightly over 1 pound, so there's an open circle, they're charging me $10. If I have 1.2, 1.3, 1.4, all the way up to 2, $10. Okay, I get to 3. As soon as it hits 3, or excuse me, I get to slightly over 2. As soon as it gets to slightly over 2, they round up and charge me $15. 2.5, etc., 2.9, $15. And then I get to 3 pounds, they charge me $15. As soon as it goes over that 3 pound mark, I'm being charged $20. And that ends at 4 pounds. So this is kind of an interesting graph because it is stepwise. Because there are multiple x's that are charged the same price. And this is still a function because each x value is only assigned one y value. 0.1 is assigned $5. 1 is assigned $5. So there's still only one y value assigned to each x. So this is still a function, and it generates this stepwise graph. Okay. Today we had an introduction to functions and graphing, which is a concept we'll be using very frequently later on in the course. Thanks for visiting educator.com.